Thanks, Ryan. Morning, everyone. My first ever in-person talk is I've done something earlier to thank you over the Google Meets, but yeah, it's good to be here. What lovely weather. Thank you all for joining us on the Saturday. My name is Kartik, and I'm an Android engineer who works at Bilu. And the next few slides, I'm going to put some icons over here, some logos. There are the clients I've worked with in the past 3.5 years or so. Oh, close to 4 now. I want you all to raise your hand if you know what that logo is, and then if you get it right, I've got goodies over here to give away. Even if you're wrong, that's fine. It's worth trying, right? So as an Android engineer, I've worked with client number 1. This is the most recent client. I saw his hand first. Sorry. Yeah, that's pointless. I'll give you the goodie later. I'm going to give it away during lunch break. Next one. Anyone? No one? Yep. It is an IB. Yeah, that's their new logo which they released last year. This should be pretty easy. You've already answered. Sorry. Yeah. ABC. That is ABC. This one's a little tricky, but not that tricky. Just a second. Anyone, take a wild guess, even if it's wrong.
Is that AGL?
It's not AGL, but it does start with A. I'll give you that hint. Anyone? No one? No? Okay. That's AMB, the AMB Capital, AMB Bank, all that stuff. The next one is actually hard. And if you can guess it, you get 2 of these goodies, not just one. Take random guesses, make it wrong, it's fine. I'll obviously give the right answer towards the end if no one guesses it. There will be a hint, but I want people to try first. There are 2 hints after this. But if I give those hints, nobody wins because then it's pretty obvious after that. No one? Wrong answers accepted, honestly.
Super bad.
Nah. Just because it starts with S. Anyway, I'll go to the next slide, but you'll be able to guess it straight away. We know what these 2 products are. It's there in the logo, but it's the parent company which makes these products. No, it's not that. Nah. It's Stream-Motion. I'll give you the prize anyway. I've decided to change my plan. All right, so across 4 years, I've worked with these projects on Android and Android TV solutions. And what I found is that there's different ways of clients managing their dependencies in Android, depending on how big or small the project is, how much of dependency sharing there is going on between the projects or within submodules of the project, things like that. So I'm here to share that knowledge and to share the different ways that are good practices as of today. And it's up to you to choose which one works best for your project. It doesn't have to be like, I'm going to follow this one because it comes recommended from me. Don't do that. Pick the best one which works for your project. If you're starting off a new project, you have 3 options, 4 options, whatever, and then see how it works out. Just to start off with some boring stuff, what is dependency management? It's basically just getting a list of all your external dependencies or even internal dependencies and managing it in a centralized way so that if there's conflicts, if there's issues going forward, you can easily resolve them and make sure that your software, your product works well for you and your customers. It's really important to manage your dependencies these days because with the open source world and half of your Android dependencies being open source, it's easy for you to get a bad piece of software. It's easy for you to have conflicts and things like that. So yeah, you need to be sure of the security behind that dependency because if there's a bad actor in that dependency, your entire package and the reputation of your product goes down. So you need to be able to manage the security of your dependencies very well. Performance matters a lot. You can optimize your own code as much as you want. But if that particular network library, as an example, is extremely slow and sluggish, your entire software fails. The quality of the code has to be good. Of course, there are many ways to solve a problem, but then there's also optimization of how you solve that problem. So being able to manage dependencies for optimal quality is quite important, in my opinion. And then licensing, open source libraries, even closed source for that matter, these days come with a lot of licensing requirements that you have to declare such and such license, or you have to cite the author of the dependency. So dependency management tools help you manage licenses as well. Some challenges that come with dependency management as we know it, and we'll see if we can kind of solve them. Conflicting dependencies. Library A and library B both depend on something called library C, but different versions. So there's a conflict now, which one will you use? So dependency management tools that I'm going to talk about help you migrate or help you mitigate these solutions and overcome these conflicts. Versioning issues. Not everyone is familiar with the versioning systems out there. I'm not talking about just Git in general, but the regular 1.2.3 version semantics that we have. So you need to your dependency management tool needs to be able to understand different ways that a developer can version their software. What is a major minor patch kind of system? What's just a string based release 1, release 2 system? All of that needs to be well understood by a dependency management tool. We often work in multiple environments. It's not like you build one and you just ship it. You, at an enterprise level at least, you have multiple testing environments and then a final production environment. And sometimes these dependencies cater to those particular environments. Like this particular dependency coordinate only works with the staging environment. That one works only for production. So a dependency management tool also needs to be able to understand that there's different kind of packages that I need to download just for different environments. And with that, I'll jump into state of dependency management in Android Studio. Dependencies in Android Studio are managed by this elephant. Does anyone know what this elephant is? That is Gradle. Yes. Gradle is a build system which comes with a plugin portal. It can serve you dependencies from various repositories out there, both internet-based, locally hosted, all of those things. So it's a robust environment, a robust system of managing your dependencies, apart from building your own software. It also offers dependency management in Android Studio. What really happens when you request a dependency in Gradle is the Gradle build system tries to look for the artifact in the cache, which it has locally. If it can't find it in the cache, it tries to look for a local repository if there's one configured. It's not restricted to any one kind of repository. It could be a Maven repository, it could be an ID repository, and anything that you have hosted locally on your machine. If it finds it, great. The copy of that artifact is stored in the cache, and everything just works from cache from there on. If not, Gradle goes to the network. Gradle is aware of how to connect to that particular repository. So at certain times, you might have an internal repository which requires, let's say, a VPN or some sort of authentication. Gradle is pretty good at managing all of that. It knows how to connect to that and fetch the artifact from the remote repository. And then all of that gets stored in the cache again, so that next build is much faster. It doesn't have to fetch it from the network again. Now, there are different ways of managing your dependencies in Android Studio itself, and these are built on top of what Gradle offers. First one is just manually declaring your dependencies. But before I move forward, how many of you are Android developers or have worked with the Gradle build system before? Right. So to a few of you, this would make a whole lot of sense. For the rest of you, if you've never worked with this before, just take my word for it, and this is how you do things in Gradle. The manual way is to just declare an implementation and hard code the entire artifact as well as the coordinates for it. And what I mean by the artifact and coordinates, So the first part before the colon over here, it's called the group name. This is the artifact name or the module name, and that's the version of that or the coordinate of that particular library. And implementation is a function which tells the Gradle build system that I want this implementation included in my build. So yeah, manually you just declare it as a string, pass it to the implementation function, and Gradle does things for you. It's really good for small projects. You just write it once and you don't really have to worry about it. But then it gets difficult to manage as you scale up. Let's say you add another module or submodule in your project, and you have to declare it again and again. And you can easily lose track of which module is using which particular version. Let's say module A is using 1.2.3, whereas module B is using 1.2.4. There could be version conflicts over there and things like that. So it gets very difficult to manage as you scale. There's a lot of code duplication because you're writing this particular sentence again and again and again. And yeah. And then you've got limited flexibility on how this can be managed better. It's just a string literal. It has no meaning in itself until it is passed to a function. So it's not very flexible in itself. Next one is using the build source module. If you're not aware, build source module is one of the special modules within a Gradle build system or a Gradle project. Gradle automatically recognizes this if you declare it in your project, and it is used to store your build requirements or build systems within a module so that it can be shared across multiple modules. We're going to take the Kotlin approach. Mic is speaking loud. This is better. Yeah. We're going to take the Kotlin approach to it. You declare inside your build source folder, you declare your versions as objects and constants like this. And then your library declarations like this. So your group name and module name goes here. And then using the Kotlin string concatenation syntax, you just reference the version number. Now this gives you two levels of modularity. You can declare a version number here. Sorry. And then you can just reference it here. So if you need to upgrade it, just simply change the version number. You don't have to, keep on changing the string again and again. And then within your build.gradle file, just call the library.myspectacular, whatever the object name was in your library's object over here, and Gradle knows how to fetch it. The pros is Android Studio is able to recognize such files. It has code completion. It also has IntelliSense and all of those things out of the box. You can easily separate your build logic using this build source module. And then it has reusability across modules. So the build source module is shared across all the modules within that project. So you can declare, you can be sure that you're declaring the same version if you're using that same object. You don't have to worry about module A having a different version versus module B having. You update the version number, it gets updated across the project. The cons over here are that build source comes with a lot of overheads of its own. It needs to be compiled before anything else gets compiled. If anything changes within the build source module, even if you go from 1.2.3 to 1.2.4, the entire build source module needs to be recompiled. That kind of creates limitations in scalability because now you're compiling more often and making the compilation slightly slower. The third one is version catalog. Version cataloging has been a concept which has been around quite some time. It's been there in Gradle for the past few years, I believe, but it's relatively new in the Android world and having first-party support in Android Studio. A typical version catalog, if you declare it in a TOML file, would have these 4 sections. You've got versions, you've got libraries, and then bundles and plugins. Ideally, you would declare a version like this. So this is now called a version reference. And in a minute, I'll show you how do you actually use those. But let's say you've got 10 dependencies with 10 version references. All of them can go here. And then your library basically has a group name, and then a name itself, which is the module, and then the version reference. You've broken it down further into 3 different parts. If tomorrow the new library, there's a library update and the name changes, you don't have to change everything. You just update the name and everything else works fine. Or if the group name changes, you can just update that, everything else remains the same. So this is how you would declare the library. And when it comes to the Gradle file itself, Gradle is smart enough to understand and parse that terminal file or that particular code that I just showed. And it automatically converts any of these delimiters like dash into dots. And then by default, libs object is available with all the parsed information from a version catalog. And then you can just reference your library like this, and then Gradle does its magic. So the pros again over here, amazing integration with Android Studio. It takes you exactly to the point where the library is declared. In fact, if you command click this particular string, Gradle will take you, sorry, Android Studio will take you here. It will not get confused what's going on, even though it's a string. It's amazingly easy to share across projects. Build source is limited to one project, whereas your version catalog is part of the Gradle folder itself. Your Gradle folder can easily be shared across multiple projects. So you've got one root project, which is just Gradle folder, and include it in your other projects. And it's faster because it's not recompiling everything every time. If you change one dependency, only that new dependency needs to be fetched. Everything else remains the same. The biggest 2 cons that I've seen in the last couple of months are it's a very boring and repetitive migration. If you're migrating from, let's say, manual mode or the build source mode, and you've got a lot of dependencies, you have to manually copy and paste them and put them in this format. But you only have to do it once. And then it requires upskilling because it's relatively new for Android developers and the Android world. Not a lot of people know about it. You all know about it, so it requires upskilling. So if you go and talk to your Android developers or your fellow developers and tell them about this, that one-time upskilling is required. It's not really a con, it's a good thing for them in their career, but yeah, it's something that not a lot of people enjoy. Next, dependency conflicts. Okay. Yeah, I'm highlighting 4 ways of overcoming any conflicts that might happen because of 2 dependencies having the transitive dependencies of different versions. One of the most common ones is to just force a particular version across the board. So Gradle has this section called configurations, and over here with this piece of code, we're declaring that for all configurations, put this resolution strategy that force this particular library to only use this version. So if another library tries to use a version higher than this one, Gradle will force the project to come down to this library version. If there is a breaking change in the library, now it's that library's problem to fix it, or you can use a different resolution strategy. One of them is called substitute. You can substitute a particular module that if the version being requested is this particular one, don't use that, use this one. Anything else is fine. And you can also specify a human readable string as a reason, so that when compiling and the substitution happens, Gradle can tell you why was this substituted. A quick example would be that you only want to use stable versions, and at the time of writing this rule, 123 was the most stable version. It could also mean that 1.2.4 as a stable has been released, and that will not get overridden. Only the alpha, 2 alpha, something like that will get overridden. So if another library transitively depends on 1.2.4, all good, you can still use that. You can completely exclude any references to this library. Just say that if a library is requesting my spectacular library, just don't include it. I will include a particular version myself. And it's a pretty common strategy because you can either use force or you can be in control of that transitive dependency. But of course, if you forget to declare that transitive dependency, compilation will fail because the other dependency which depends on it can't find it. And then there's this completely disable all transitive dependencies. This one is for this particular implementation only. Like, do not include any transitive dependencies coming in from this particular dependency. But you can go one step higher if you need to, and just outright disable all transitive dependencies and be like, I don't want anything. So these are the two options available for disabling the transitive dependencies. There are more methods. It's all documented on Gradle, but they require more complicated configuration and use of further advanced APIs. So I'm not going to be covering them here. However, it's all available. I should have put a QR for that here. Dependency updates. Now, we've seen how do you manage dependencies, how you declare dependencies in different way, how do you work with conflicting dependencies. But dependencies change frequently, and you would want to, stay with the latest version of what's come out. I found this particular plugin. It's called Gradle Versions plugin. It's open source, and what it lets you do is, well, it does things for you. It determines which dependencies that you've declared have an update available. It is customizable, so you can say only look for RC builds or only look for alpha builds or completely ignore anything but stable. All of that fine-tuning is available. And then it gives you a nice formatted report in a format of your choice. There's TXT format, there's HTML, JSON, XML formats, whatever works best for your pipelines. And once included, all you have to do is run this command. You can use this command as part of your build pipeline as well, so it can give you a nice report every time. I'll show you how it works in a demo in just a few moments. Okay, now you've done all of this. Now, there could be a better way if you were working on a plugin, let's say, or you're working on libraries, or let's say you've got a complex project with over 50 modules, which have a lot of shared code in your build scripts. You can now start sharing build logic. And this is also powered by Gradle's dependency management system, just through a plugins perspective, not necessarily through a dependency perspective. You can break down your build scripts into individual plugins and put them wherever necessary. So there are two ways to do it. You can improve the readability and maintainability of your project and the build script itself. It's easier to maintain because if you want to just change one part of that build script, you only change that. Everything else remains the same because you've now broken them down. And they're all each individually testable, so you've got more confidence on those. And it's easy to share the configuration across projects. You can shove them into a different project, or you can publish them as an actual plugin, either on the internet or your local repository. It just works. It makes it obviously easier to automate your build tasks because now you've got them as separate plugins. You can run them in parallel. Well, the first one is the convention plugin, and as the name suggests, it's just a plugin which says this is the convention of how we do things for this kind of thing. Take an Android project, for example. You can have a convention for declaring how do we set up Kotlin for this project and put it in a separate plugin. Have another plugin which declares the convention for declaring my compile SDK versions, my package names, and all those things in a separate plugin. Put them somewhere else, and then use them in your module, library module, or your project module as required. The other one, which is becoming more popular now, is Gradle precompiled scripts. And it's more popular because with the convention plugins, you have to use the full Gradle API to declare your plugin. Whereas with precompiled scripts, you just write it like a regular Gradle file using the same DSL. It just gets packaged all of it gets packaged in a jar, and then you can use it as a plugin. So it's making it easier for you to write plugins rather than learn the new syntax for Gradle APIs. Okay, it's time for demos. How are we doing on time, Ryan?
We have a lot of time.
Yeah, that is good.
15 minutes.
Perfect. Thank you. Okay. I hope this is visible all the way to the back. Clear enough? Okay, so I've got this random project. I've got 3 or 4 different branches, and I'm going to show you how it really works. And then I'm going to do a build comparison as well. And for build comparison, I have this nice little script called benchmark.sh. All it does is it calls the clean command on Gradle. We run all the tasks required to compile the debug sources and profiles them. And what the profiler essentially does is it gives me an output of what task took how much time. I only care about the total time right now, so I'll have that metric, and then we put it on a spreadsheet and compare it. So this is the hard-coded one. Nothing's declared or managed anywhere. Everything is right here in one file. So I've got the namespace here, the declaration of compile SDK, build tools version, anything that I would need to configure my build script is right here. All the signing keys and everything. All my dependencies as well are just super hard coded. They're not managed somewhere. And if I were to run the benchmark on this one, so this took about 5.538 seconds. Yeah, the total build time is 5.538 seconds. I'll add this to the spreadsheet. We just take, well, this is not zoomed in. Okay. We take hard coded as a benchmark because we know hard coded is not a good thing. Yeah, and we'll see how build source and version catalog methods behave. Okay, so now I've got this build source folder over here, which is the special module. And at a hierarchical level, you can see that it sits next to the app module and the Gradle script section. If I go into the code itself, I've got all my versions declared like this, and the libraries like this, which refer to the individual constants in versions. And then I've, just for separation's sake, I've put some Android config separately, the compile SDK, min SDK, and all those things. And then if I look into my build.gradle file, I can just easily get them from the particular object itself. And it's got code completion as well. It'll suggest whatever I need, and I can just press namespace. It's there. So let's compile and see how this performs. This one took 6.142 seconds, which means the build overhead of build source is kind of factoring in. What was it? 6.142. So it's about 11% slower than the hard-coded version we just saw. And just to let everyone know, they both have the exact same dependencies with the exact same version numbers. I have not made any changes. It's just different. It's just how they store it differently. Now going to version catalogs. Now you'll notice that build source folder is gone because I don't need it anymore. And you have this new thing called libs.versions.toml. That's the file where I'm storing all the information required for my dependencies. We've got all the versions here. We've got libraries declared with group name and version number references. And then additionally, you can have your bundles together and plugins together. What bundles does is it lets you bundle a few of your libraries together. So when you're calling them in the Gradle script itself, you don't have to write multiple lines. It's just a syntactical sugar on top of what you already have. And if I go to Gradle file, libs, if your toml file name by default is lib.versions.toml and you place it inside the .gradle folder of your project, Android Studio knows how to use it. You don't have to do anything special. However, if it's a different file name, you'll have to write the code to include that version called catalog in your settings.gradle file. And then it's available as an object over here. It's got, like I said, it's got the code completion and everything. And with the version references over here, you can share the same version number across multiple libraries if they support the same number. Typical example would be Gradle plugin, which can be used for libraries, regular app projects, and all those things. Running a benchmark on this. Okay. 5.916. Slower than hardcore. I get different results every time. But it says about 7% slower. This is the first time both of these are slower than hard-coded versions. But yeah, it's a live demo, so it is what it is. Okay. So that's the build comparison over here. What else? Build comparison. Yeah, so I've got it here on the slides now. Like I said, it's the first time build source and version catalog are proving a point, not proving a point I was trying to make. But this is a simple project, and a lot of factors can change how they behave. Like just yesterday night, I updated to Android Studio Canary 17. So there could be, and with that comes with the build Gradle plugin Alpha 17. That could be a reason why everything else is performing slow. I was on 15 before that, and everything was proving my point. But yeah, like no opinions over here. You choose the method that works best for your project. If you're in a multi-project environment, version catalog will probably be helpful because you can share your dependencies. Anyway, I rambled. And that's about it. Thanks for listening carefully, and I'm open to questions now. I think I forgot a couple of demos. Do we still have time?
We've got 2 or 3 minutes, time for 1 or 2 questions.
All right. If you still have time after questions, I've got a couple of other demos. You had a question?
Are there tools to automatically move between different systems? Because if they all have the same information, they all have the same dependencies.
That's a very good question. I haven't come across one yet, but it's mostly because I haven't researched it properly. But there is definitely a way of moving from hard-coded to version catalogs. Somebody made a plugin for that. It generates the common file for you, and then the dependency updates plugin that I showed you. There's a plugin on top of that. What it does is it automatically recognizes those updates and updates your common file as well. So that's the second level advantage. I'm not too sure about build source to anything else.
Yeah, when you said it was boring, I was thinking that it would be something to automate.
Yeah, I mean, it's the open source code. I'm sure somebody has made it, just doesn't have enough traction.
I'll spend 6 hours making it rather than spending 20 minutes.
Yeah, exactly.
Any more questions?
Yeah, we're good. Do I have time to quickly show a couple of demos?
Yeah, you've got 3 minutes, is that now?
Okay. So with this one, and I'm quickly going to demonstrate it over here, is I've added 2 library modules, library 1 and library 2. They have no implementation in them, but the only thing I wanted to show you was the Gradle convention plugin and Kotlin scripts. Right now, they've got this big chunk of library modules on Gradle 5, and this is what you'd see typically as well. They're both using version catalogs, and my next goal is to break them down into whichever I can. Okay, with the pre-compiled script, once I've got the pre-compiled script ready, the individual library Gradle script is now just displayed. Everything else is in the library itself. Once it compiles, so I've got this folder called build logic. Does the same job as build source, but it's not automatically recognized. So you have to write rules for that. And where did it go? There it is. Yeah, so where did my files go? There's supposed to be a couple of Kotlin files here. I can't find them. Okay. I was showing the wrong project. You know what? I'll just disband this demo. It's gone horribly wrong. But yeah, I'll figure it out what's going wrong. And if anyone's interested, I'm here the entire day. Thank you.
Thanks.